Alright, so let's look at how to use ratios to solve the missing side in similar figures. The first thing we need is two similar figures. So I'm going to draw two rectangles for you. Here's one, and here's the other one. And I'm telling you that they are similar. That means that they are the same shape, they are just different sizes. So, for instance, let's say that this side is 12, maybe this side is 3, and then we have this shorter side over here. We'll say that it is, I don't know, 8. We want to find the missing side over here, x. So how do we do that? Well, all we have to do is set up a ratio of the sides, and because they're similar, it is going to be proportional. So we're going to start with we'll do the big one, the big rectangle, and we're going to make it as a ratio over the small rectangle. So if you look at the first side that we have in the big rectangle, we have that 12, and the corresponding side, there's our 12 there, the corresponding side in our similar figure is this one, that 3 there. So that's going to be 12 over 3. And this, because they are similar figures, is going to be proportional or equal to the ratio of the other sides. So the other side, I'll do it in red, the big rectangle is 8, and of the smaller rectangle is x. So now we have our proportion, and we can go ahead and solve for x. You could either do this by the cross product, or if you think there's a number that you can divide or multiply by. For this, we'll do the cross product. So we'll say 12 times x equals 3 times 8. 12 times x is just 12x, and 3 times 8 is 24. So 12 times x equals 24. We know that 12 times 2 is 24, or 24 divided by 12 is going to be 2, so x equals 2. That's it. We've solved our similar figure using our knowledge of ratios and proportions. Let's try one more. I'm going to clear this screen here. There we go. Alright, let's say we have two similar figures. Say it's a triangle. There's our one similar figure and our other one. Boom, over here. Alright. And let's give them some numbers. We'll say this big side is going to be, let's make it 20. And we'll do a shorter side, we'll say it is maybe 5. Hopefully this works, I don't know. In our smaller triangle, we'll say we have one side, let's say it is 4. And we want to know the other side, we'll say it is, oh, did I draw the, which side would that be? I have to rotate this in my mind, guys, sorry. We'll say it's this one. Now, the figures don't really look perfect here, but anyway, we'll do this anyway. So we're going to make this the same thing. I'm going to go from big to small. You can go small to big, it doesn't matter. But we'll do the big triangle over the little triangle. So our first ratio we'll look at, I'm going to take that biggest side and I'm going to do it in pink. So this 20. So what side on the smaller triangle does this correlate to? Well, if we look, it is opposite this right angle here. So I'm going to look at the side opposite the right angle. So it is the 4. So I'm going to put it over 4. And I know this is going to be proportional to the length, to the ratio of the other sides. So I'm going to put equals. And if we look at the other sides then, this side in green is 5, and on this one it is x. So 5, the big one, over the little one, x. And let me put that, I didn't put that in pink to make it clear. There we go. So those are our ratios. Now that we have it, we can solve for our proportion. We can cross multiply if you want. Let's do that. So we have 20 times x equals 4 times 5. That's our cross multiplication. So we have 20x equals 4 times 5 is 20. So if we divide 20 by 20, x is equal to 1. We have now solved this proportion. If you didn't want to cross multiply, you can see on this one we have a little bit of a thing here. We can do 20 divided by 4 equals 5. So 4 divided by 4 equals 1. So we can do it that way as well. But cross multiplying will always give you an answer, where sometimes it's more difficult to see what we can divide or multiply by. So I hope that answers a couple of your questions. So remember, we're just making a ratio of the sides that correspond to the similar figures. And just make sure that you keep those ratios the same. I started with the big triangle as a numerator and the little triangle as the denominator. So I made sure that this was the big one and this was the big one, and then the denominator were both the little triangles. You can switch that, of course. You can go little triangle over big triangle, but just make sure that you're consistent, otherwise your proportion is going to be incorrect. Alright, and that's all.